Before we look at the animation, I want to show you how it is we got these other shapes. The four basic shapes that I showed you are when the electron groups, the number of electron groups, and the number of atoms bonded are the same. So electron groups and atoms bonded, that's how you get these main basic shapes, main basic geometries. Okay, so let's see how we get these others. So for example, let's look at tetrahedral for a minute. On tetrahedral, if there are 4 electron groups, so it would be something like this. Four electron groups, 1, 2, 3, 4, and 4 atoms attached, then there are no lone pairs. But if it has 4 electron groups and 2 atoms attached, then there must be 2 lone pairs. And the same, I could say the same thing for 3. If there's 3 atoms attached, it must have 1 lone pair. So the number of atoms and lone pairs is going to be equal to the total number of electron groups. Okay, and just to quiz you, if I consider this one, it has 5 electron groups and it has 3 atoms attached. This one must have 2 lone pairs and 3 atoms. Okay, let me show you how that affects these shapes. So let's look at tetrahedral again. Tetrahedral is that shape where you have kind of a little triangle, a little pyramid. It has, right there is the central atom in the middle. So this is the base that makes a triangular base that's kind of on the ground, and this one points straight up. Okay, in this case, it has 4 electron groups, and we're counting these are the single bonds, 1, 2, 3, 4. By the way, they could be double bonds and they count as one group still. But anyway, so 4 bonds, 4 electron groups, and there's an atom on each one. So the molecular geometry of that is still tetrahedral. That's what these are over here, molecular geometries. So the electron geometry is tetrahedral, and the molecular geometry is tetrahedral. Okay, but what if, so that's with 4, what if there are only 2 attached? Let's just do 2. So the electrons will be in the same arrangement in this tetrahedron, but now 2 of those places will have lone pairs. So I'm going to put my lone pairs here and here. Doesn't matter where I do it, it's just going to be easier to see the name. So, and then I'll put these here and here. So that's how on this one the electron geometry is still tetrahedral, because then I'm still looking at just the electrons. But if I look at just the atoms, I get this shape. It's bent 109.5. That's what we call, just looking at the atoms, molecular geometry is bent 109.5 degrees. Okay, next thing, let's do this one. Okay, so this one has 5 electron groups, and the basic shape that I gave you is the trigonal bipyramidal. It's the triangle shape with 1 up and 1 down. So the central atom's right there, and it has 1 up, 1 down. That's how it looks when it has atoms in all 5 electron groups. That's this one. And so this one would have electron geometry, trigonal bipyramidal, and molecular geometry, trigonal bipyramidal. Let's do this one though. It's important to kind of know where to take off the lone pairs on these two. On this one, or where to put the lone pairs. On this one, the lone pairs go on the triangle. And not the top and the bottom. On this one, the lone pairs go on the top and bottom. Okay, so anyway, let's do this one with 5 electron groups. So we're going to start with this trigonal bipyramidal shape. But now when we put the atoms on, there are only 3. And as I just said, the lone pairs are going to be on the triangle. So how many lone pairs does that have? Well, it has 5 electron groups, and so if there are atoms on 3 of those, this has 2 lone pairs. And so on this one, again, if it has lone pairs, they're going to be on the triangle. So I'm going to put one back there and one back there on the triangle. Here's an atom. Here's my central atom. Here's an atom. Here's an atom. So the central atom has 3 atoms attached and 2 lone pairs. We call this shape T-shaped because it kind of forms a T like so. And that's how I get this. Okay, I think you're ready to watch the animation. It'll show these shapes where they look like real atoms and everything.